Alright. Um, hey there, chemistry. It occurs to me, right? People have been emailing me, and I've been doing my best to answer them, like, pretty quickly, because I know that you guys are trying to do the work. And submit the work, sorry. But, um, people are wondering, like, where's the video? Where's the video, right? I said there would be a video that would go up to talk about, how to do these questions, because I went over these notes, right, the possible charges for an element, and I said we're going to bust this up into its ions, right, the ions that make it up. So I just want to show y'all where this is actually located, and what I've just found out, right, is that it looks slightly different on mobile. I'm always doing this from a computer, whether it's a desktop or a laptop, even a Chromebook, right? Any kind of non-mobile interface will look like this. So this is my day, right? I can click on a chemistry class. This is a bulletin board. I can see the topics, right? This is the most recent topic. I had them backwards before. It occurs to me I should just leave the most recent thing as the first thing that you can see, right? Other than labs. But so if I click on this, then, these are the notes that we've done so far, and here are the videos, and we're about to get some inception happening here because it's me, right? Shh, no, don't talk. I don't want to listen to you. But if you look over here, right, there's this arrow. There are these arrows that go left and right. This is video, I'm pretty sure you can see it just there. It's video 1 out of 3. There's another video. All right, this is, and I try to label it also by like letter day, right? So this is the B day. So we had, no, don't talk. A day. Right, I got B day. That's video 2 of 3. So this is talking about identifying ionic compounds versus covalent compounds. And here's, I called it B2. I should have called it like second B day. I don't know. It's like second breakfast or something. This was finding oxidation states. So this was the notes on page 22 to do the examples on page 23. All right. But I just wanted to let you know that there is a way to get to the other videos. Now on mobile, it's hard to kind of tap on the arrows here. So I would kind of strongly recommend doing this on a computer if you can, if you're able. I'll work on making this a little more mobile friendly, but there are only so many things that I can do and I can get my hands on given the amount of time in the day. Anyway, let's get I don't want to look at myself. Let's get back into this. I do want to go over these examples, right? Because I feel like y'all will want to see how to do this properly, right? Find the oxidation number, find the oxidation state, find the charge on the elements and the atoms inside these compounds or polyatomic ions. Everything is shaking because I just accidentally hit my desk. Apologies. Well, I guess just like my little section of the bubble up here. Anyway. So let's take a look at this, and let me use a small print pen. So, it occurs to me that I should probably open up a reference. Where's my mouse? There we go. I should probably open up a reference table. It's a very professional and well-made video, and y'all can't tell me anything to the contrary. I am doing great, just like y'all are. Okay. So here I have a periodic table of the elements. Okay. We'll need this, right? So let's look at this. What's the oxidation state? So what are the charges for... Oh, that is not small enough. Do I need the smallest one? I guess I need the smallest one. I want the charge. What is the charge for Na? What is the charge for Cr? And what is the charge for O? Right? Now sometimes it's nice and easy because I look for an element like Na and I look in that top corner and the only thing that I see right here is a +1. That means that my Na's charge is +1. Done. Right, Cr. So I go back here, I look for Cr, there it is, here's Cr, and I run into a problem. Because if you look down there, where the cursor is, Cr has 3 possible choices, and I told you I did not want you guessing, so, for now, skip it. we have to look at oxygen. Okay. Oxygen, 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 oxygen. Here it is. It has to be a -2. Alright, that's actually pretty helpful. So now I know for certain two of these. I know Na is +1, and I know O is -2. And what I'm going to do is I'm going to just... Unbelievable. What? There we go. I want to center this. I want to get a little closer to this. So what I'm going to do is I'm going to figure out how much total charge do these NAs make up, how much total charge do these oxygen, do these O's make up. Right, I have 2, the subscript 2 next to Na tells me that I have 2 of them, so my total charge here is +2. My total charge for oxygen is -14, because I have 7 of them. There's 7 of them, and they're -2 each. Now, because this is a compound, all the charges have to add up to equal 0. So, I'm pretty sure I muted that. Like I said, this is super professional. I'm doing great. All of these charges have to add up to equal 0. So I don't know what CR is, so I'm just going to call it X. But I know that +2 plus X minus 14 has to equal 0. So if I hit this math, let me add 14 to both sides, sorry. So I have 2 plus X equals 14. Then subtract 2, so I know that X equals 12. So the total charge on all of my CRs is 12. If you look, right, there are 2 of them over there. Which means that I have to take this 12, and I need to split it up into 2. I need to divide it by 2. Which means 12 divided by 2, my CR, my chromium, is actually a +6. Right? And if I double check myself, CR, chromium, one of the options down here, was +6. So we're good. Now I will say that this was the most complicated one here. And the reason it was the most complicated one, that's the only one that had 3 elements. Everything else is only 2 elements. So they're comparatively much easier. Let me explain what I mean by that. FeCl3. So I need to figure out what's the charge on Fe and what's the charge on Cl. If I look for iron, I would find it here. There's 2 possible charges. Not useful. But Cl is my other one, and there are multiple charges. Not useful. Or so it seems. You might be thinking, Kalimlin, you said we wouldn't be guessing. Alright. I was being truthful, right? You're not going to be guessing. Look at iron. Right? Fe has to be positive. If I want the whole compound to be neutral, the only option for Cl should be negative, so my Cl has to be -1. So I'm going to go back. I'm going to label my chlorine is -1. Now I have 3 of them. That's a total of -3 charge, which means the iron has to be a +3. Boom. That's it. Done. Alright. I'll do the same thing for number 3. I have this nickel. I'm going to figure out what it is. I have this oxygen. Well, hang on. We just did this a second ago. Oxygen, right here, is a -2. Well, -2, right? In order to balance that out, nickel has to be a +2. There's a small difference here in 4 and 5. They are not compounds. They are polyatomic ions. Which means the total charge is not going to add up to 0. It's going to add up to that listed charge. Alright, what's C and what's O? Now we've already established many times that O is -2. So 3 of them at -2, that's -6. I don't know what carbon is, so it's going to be X. And so X minus 6 has to equal -2, because the whole thing has to add up to a -2 charge. I'm going to add 6 to both sides. That means that X has to be +4, so my carbon must be +4. The same process for this PO4. right? Oxygen must be -2. The total charge is -8. It has to add up to -3. I don't know what the phosphorus is, but if I add 8 to both sides, then I know that the phosphorus has to be +5. All right? So this process is going to be important for the next bit. All right? I'm going to split this up into 2 videos because I can already see that I've gone like 10 minutes here. It'll probably take me about another, oh goodness, probably take me about another 10 minutes to do the next page, which is page 24. So I'm going to cut this video off here. I'm going to label it like, going over page 23. The next bit will be what we did in class, which is page 24, going into page 25. See you soon.